Welcome. In this session, we are going to look at a couple of more examples related to the power rule. Both of this illustrate the need to do some simplification before you can apply the power rule. If you have a fraction and the denominator consists of a single power of the variable, or perhaps a constant times the power of the variable, then you can distribute the denominator and then use the power rule. As I mentioned last time, there is no quotient rule in integration, which means if you have a fraction, in general, there is no method that always applies. There are different methods for different types of fractions, and this is the simplest. If the denominator is a single term, distribute it over the numerator. Write the function using negative exponents if necessary, and then apply the power rule term by term. In this example, I have 7z cubed minus 3z power 7 over z power 5. So if I distribute the denominator, I get 7z cubed over z power 5 minus 3z power 7 over z power 5. Z cubed over z power 5 is z to the power 3 minus 5, or z to the power negative 2. So the first term is 7z power negative 2. Z power 7 over z power 5 is z power 7 minus 5, or z squared. The second term is negative 3z to the power 2. And to find its antiderivative, I can integrate term by term. An antiderivative for the first term is 7z to the power negative 2 plus 1 over negative 2 plus 1. Negative 2 plus 1 is negative 1. In the second term, I have the coefficient negative 3, which stays as it is. For z squared, an antiderivative is z cubed over 3. If I add 1 to the exponent, 2 plus 1 is 3, and then I divide by the new exponent. That gives me the 3 in the denominator. Of course, I have the constant of integration. So the answer is negative 7z power negative 1 minus z cubed, or if you prefer fractions, you can write that as negative 7 over z plus minus z to the power 3 plus c. Just as there is no quotient rule, there is no product rule in integration. So again, in general, if you have a product, then the only thing you can do is multiply it out. There are some special situations where products can be handled differently. One of them occurs in the method of substitution, which you will see later. Another one occurs in what is called integration by parts. I might describe it if we have time after finishing chapter 14. Integration by parts is very special, and there is really just one type of situation among the functions we know where it's useful. So we won't spend much time on it. So in any case, to integrate something like t power 3 plus 1 quantity squared, you just have to multiply it out. You can write that as t cubed plus 1 times t cubed plus 1 and FOIL, or apply the rule for squaring binomials as I'm doing here. In either case, you get t power 6 plus 2t cubed plus 1. And then I can integrate it term by term because it's just a polynomial. So in each term, keep the constant coefficient as it is, add 1 to the exponent, divide by the new exponent. So for the first term, t power 6, if I add 1 to the exponent, I get t power 7. And I divide by the new exponent, that's divide by 7. So I get t power 7 over 7. The second term, the constant coefficient is plus 2. I have t cubed. If I add 1 to the exponent, I get t power 4. Then I divide by the new exponent, 4. The last term I have plus 1, and antiderivative is just t. You can think of it as the power rule for t power 0. Add 1 to the exponent, you get t power 1 divided by 1 is t. It's much easier to remember that an antiderivative for 1 is t. And of course, you have the plus c at the end. We can leave it like this, or I can simplify this a little bit. 2 over 4 is 1/2. So it's t power 7 over 7 plus t power 4 over 2 plus t plus c. This concludes our look at the uses of the power rule.